Okay, so here's my presentation on endosymbiosis, which evaluates the endosymbiotic origins of the mitochondria and the chloroplasts. There's two different theories that have arose from this that scientists have studied to find out where they may have came from. The first one is the endosymbiotic theory. This one has four main points of proof. It's this top area. And the four lines of evidence that support the hypothesis is that the chloroplasts and mitochondria are surrounded by at least two membranes, and they found this out by studying the membranes. It looks as if one prokaryote, this is a prokaryote host, had swallowed another prokaryote by phagocytosis, and it ended up living in a symbiotic relationship. Chloroplasts and mitochondria have their own chromosomes separate from that in the nucleus, which is also a similar characteristic of other prokaryotes. Chloroplasts and mitochondria also reproduce by binary fission, as do other prokaryotes. So they are pretty similar to other ones, so that's where they may have gotten the idea that the mitochondria and chloroplasts were at one time free-living prokaryotes, but they became ingested and started living in a host prokaryote. The fourth point is chloroplasts and mitochondria have ribosomes that are similar to prokaryotic ribosomes, including several different kinds, including a 50S large ribosomal subunit, 30S small ribosomal subunit, 3 RNA species, and approximately 50 other proteins. Ribosomes found in the cytosol of eukaryotic cells include a 60S large ribosomal subunit, a 40S small ribosomal subunit, and 4 RNA species and 70 to 80 proteins. This sounds pretty convincing that it could have been where mitochondria and chloroplasts may have originated. Now, taking a look at the other theory, it's called endogenous origins. Now, this one has the idea that the cell membrane of the prokaryote invaginates and pinches off, leaving membranous internal vesicles, which I don't think that just the chloroplasts and mitochondria would have emerged from this. Other organelles probably would have, as suggested in number 2. Vesicles becoming associated with catalytic processes giving rise to vacuoles, Golgi apparatuses, ER, which is endoplasmic reticulum, chloroplast, mitochondrion, etc. Chloroplasts are the power. They use photosynthesis to get energy for the cell, which would be the catalytic process the prokaryote would have been using that organelle for, as well as mitochondria being the powerhouse of the cell, essentially. Now, to contrast these two, you can talk about how different they are by how one of them is saying that the mitochondria and chloroplasts were free-living prokaryotes, and the other one suggests that compartmentalization was how they came to be in this prokaryote. Or you could say they're either the cell ate it, or it was derived from the plasma membrane. And that is my presentation.